All right, hello everybody. Thank you for coming to listen to Tim and me talk. I'm CJ, this is Tim. Tim's co-chair of SIG-Auth in Kubernetes, and then we're both on the Product Security Committee.
Just click here. Nope, there we go.
Okay. Yeah, so if any of you were at the summit last year, you might be wondering, hey, didn't I already see this talk? And yes, you did. We gave a similar talk last year, but it's 2019 and there's more new stuff. And it turns out that not everybody has all the free time to attend every single SIG-Auth meeting and parse through every single line of all the release notes that we've had over the years. So we're gonna give you the spiel for this year. So what are we going to tell you about? We're going to start off kind of reviewing the cool things that happened in 2019, including stuff that maybe you might consider not cool, CVEs, although they're fun to talk about too. We're going to go through some of the things to be aware of, some of the hot topics, the interesting stuff that is currently going on in the security space, and finish up with a kind of what can you all do to help us out. So a lot of you might have heard about this Product Security Committee. We used to be called the Product Security Team. We're now a committee, which gives us an official state in the Kubernetes landscape. So PSC is responsible for incoming disclosures about potential vulnerabilities and then managing the fix and release process and comms as we disclose those and send out patches. So we've had some new members on the team. This past year, Jess Frizzell stepped down from the team, and Brandon Phillips is also making plans to relieve himself of some of his responsibilities. A lot of the structure and process we have today is due to Brandon's diligent hard work, so we'll definitely miss him, but he's earned his escape. So this year, we added an official on-call process for our Product Security Committee. That means there is a person that is actually tasked with responding to those incoming emails. And we do get a lot of emails, and they're mostly not spam. So people are looking through Kubernetes trying to find out things that are wrong and could potentially lead to security vulnerabilities. And so out of the, what do we have, 159 reports, we actually had 15 CVEs that were graded out as medium or higher that we sent out disclosures about. So here's the list. I went through and I tried to grab all the medium or high CVEs that we dealt with this past year. I'm not going to talk through them all, but I encourage, if you have time or interest, go ahead and look through these on your own time, both as a fun little project and to help us think through the places where these bugs tend to hide, and maybe you can come up with one that'll end up on this list for 2020. I am going to talk about a couple of the interesting ones we saw. If you were hanging out on the security announce list, you probably saw several iterations of this kubectl CP bug. So it was a client-side file modification vulnerability where if you ran kubectl CP against a potentially malicious container, the tarball you got back could actually expand a symlink outside of where you were extracting it and cause some files that you were not expecting to get modified to be modified. So we fixed the bug, and then it turned out people were fairly ingenious with coming up with new ways to trigger basically the same behavior, combining symlinks and playing games with the order of operations within kubectl CP. Fairly happy with what we ended up with for a solution. We think it's pretty solid. But in 1.16, we basically just said no symlinks in kubectl CP. So easier fix there. The other sort of class that we saw come up this year a good amount of times were these DOS vulnerabilities. So this first one, the JSON patch library, the Kube API server supports the JSON patch content type, which allows you to send a fairly concise payload that indicates to the API server, here's the changes I want to make to this object. They might be fairly complex. Lets you do a lot of interesting stuff. Turns out that interesting stuff can also be, let's make the API server run around in circles for a really long time. The second one was a bug or a potential inefficiency in the Go HTTP2 stack. Basically, throw a bunch of pings and resets at it, and you can make it allocate enough memory to eventually fall over. Last one was a YAML, similar to the first one. A bug. YAML has this awesome aliasing feature where you can indicate that you want to repeat the same object a bunch of times. Turns out if you nest those enough, you can get up to 1 billion fairly quickly. So all three of these had a couple things in common. They were DOS vulnerabilities, so we're starting to move on to the world where we have to consider that the Kube API server has expectations about being up for its various tenants. They're also treading into the world of dependencies. So each one of these we had to manage the process of actually updating a piece of our core of our dependencies in Kubernetes and getting that done and then getting that rolled out. So luckily with each of these three, we had thoughtful, responsive maintainers that worked with us to get these in a reasonable amount of time. That may not always be the case, and so Tim will have more to say about our dependency situation later. Anytime we start talking about DOS, the question comes up about this anonymous auth flag in Kubernetes. So anonymous auth is a feature that allows anybody to talk to your Kubernetes API server, and if they don't present credentials, they flow through the system as part of this magic group called System Unauthenticated. This is useful if you want to have a health C endpoint where a thing that is doing your liveness probe doesn't have to have credentials to be able to talk to it. It's also potentially dangerous, as we see with some of these vulnerabilities that are made worse by being exposed to whoever can talk to your Kubernetes API server. So my opinion is that anonymous auth is a valuable enough feature. And the good news is that we hardened the default bindings in 1.14. So we reduced the default set of APIs that are open to this anonymous access. A note though, this applies to newly created clusters in 1.14, so if you created your cluster before then and you've been upgrading it along, maybe take a look at applying these newer bindings. Another cool thing that happened this year, we had our first third-party security audit of Kubernetes. The big things that came out of that, we got a threat model, and we got a pretty thorough security assessment, which came up with some potential vulnerabilities for us to go fix in the code base. If you want to learn more about that, there's a talk tomorrow and another one Wednesday in the main track. Another thing which I'm really excited about, these service accounts. So if you've used Kubernetes, you've used service accounts, your pod ends up with this JWT token mounted as a secret. You automatically use that token as part of the client libraries to get access to the Kube API server. There's a couple of downsides to this legacy way of dealing with service account tokens. The tokens don't expire, and they're not scoped. So if one of these escapes, you kind of have to notice. They're rotatable, but you have to notice, and you have to do some work. They are also usable against your Kubernetes API server from anywhere, which means you don't necessarily want to use them for external integrations. So we now have this new way built on top of the token request API. Instead of pre-filling out a secret and then mounting that, the tokens are generated on demand by the kubelet who mounts them into the pods that request them. Those tokens have an expiry and they have an explicit audience, which means the tokens for your Kube API server should be only usable there, and you can request tokens for other things, which allows you to do cool things with integrations. Now, this all happened last year. All the code went in I think 1.12 to make these features exist. So why am I talking about it now? We actually got some usage out of this in 2019. So in 1.14, we migrated some of the core controllers to start using this flow. That was a really big step. And then there's at least 2 cloud providers I know of that are using these new tokens as the basis for their identity integrations with their cloud APIs, which is really cool to see this uptake. And with that, I'm going to hand it off to Tim to talk about the node restriction feature.
Thanks. Yeah, so in 1.13, we started scoping down a bit more what nodes are allowed to do, specifically kubelets. We talked about that last year, but we've continued to kind of iterate on that. and continue to roll out more label restrictions. In 117, we added restrictions on owner references, and there's a proposed KEP. It was originally targeted at 117, but probably hit 118 to restrict what mirror pods can be labeled with. But is all this enough? I'm just going to shamelessly plug my talk tomorrow, where we'll do a deep dive on node isolation and some of the other problems outside the node restriction controllers. So let's talk about some hot topics, kind of switching over to current things that are going on. So PodSecurity policy fills an important hole in it by restricting what can actually run in your cluster. But there are some problems with PodSecurity policy today. The first is a sort of flawed authorization model. The way it works is you can bind a policy to a user who can use that policy, or you can bind that policy to the pod that you're creating's service account user. Which is kind of confusing. And it turns out the latter way is actually the right way of doing this. And if you go with the first way, you can get some unexpected breakage later on. It's really difficult to roll out PodSecurity policy because it's a global configuration for the whole cluster. You have to have policies enabled on every pod before you can turn it on. And it's also kind of grown over time, and so it's got this kind of inconsistent API, which is, we could clean that up. But it's also sort of unbounded. We don't have a good definition of what belongs in PodSecurity policy and what should be delegated to other policies. And so with all that, PodSecurity policy might never make it to GA. This is something we've been talking about in SIG-Auth lately, and trying to figure out what is the future for this important policy API. Some alternatives we're exploring are Gatekeeper or Caverno. These are different plugins through the admission webhook API that kind of generalize this idea of policy and also template it to make it a little simpler. David Eads proposed integrating OpenShift security context constraints into upstream Kubernetes as an alternative to PSP. This is going back to PSP's roots. And we've also talked about some built-in minimalist profiles. So this is all under active discussion, and we'll be going deeper into this in the SIG-Auth session on Thursday. So if you want to talk more about that, come and join us there. The image promoter, just a show of hands, who here has heard of the image promoter? Okay, a few of you. So right now, the way Kubernetes production container images get pushed is if you do not work at Google, you find a Googler and you ask them to push the image for you. So obviously for a open source project like Kubernetes, this is less than ideal. And the image promoter is trying to solve this problem. So the new way is you have sub-project owned staging repos. And so a contributor to that sub-project can get access to push their image directly to the staging repo. Then they submit a PR to the image promoter manifest, which says, copy my staging image over to the production repo. That gets approved by a project maintainer, and then the image promoter bot pushes it to production. So why is this a security, why are we talking about this in a security talk? We've gotten away with being a little lazy with how we build and push images. In part, that's just been leaning on Google security to assume that it's okay. But as we open this up to the world, where anyone can potentially be pushing these images to production, that kind of worries us a little from a security perspective. Kubernetes doesn't have a security operations center. And so as we open this up, we're also going to be working on migrating towards a more kind of CI/CD oriented system where rather than building these images on individual developer computers, we're building them through a CI/CD pipeline. And so a person doesn't actually need to do the push at all. And really, we should have done this a while ago. So happy to see it happening now. An update on the bug bounty. I think we mentioned this last year that it was coming or that we were talking about it. We now have a vendor. We're working closely with HackerOne. We have weekly sync ups. And we've launched the program in a sort of private alpha state. We've got 12 submissions and we've awarded 1 bounty. That probably doesn't sound like a lot, but it's actually been really helpful in figuring out, helping us fine-tune the policy for the bounty and figure out how the process works. So we're excited to launch that sometime in Q1 in 2020. All right, now for my favorite part of the talk, when I get to complain about things. So the first is vendor dependencies. We mentioned this last year. We called it out as a problem that we have a lot of vendored code that's kind of stale. And unfortunately, the situation hasn't gotten a whole lot better since then. So last year was around 113. We can see that actually our vendor dependencies have continued to grow since then. If we consider golangs.org/x an extension of the standard library, then it looks a little better, but still sort of flattened out. This is a concern from a security perspective because, one, that's a lot of attack surface. We have twice as much vendored code as actual Kubernetes code. And although a lot of that vendored code is coming from projects that are well-maintained and have good security posture, we don't know what the status of all of those vendored projects are. And even if it is a well-maintained project, we don't always do the best job of pulling that code into Kubernetes and keeping track of security issues in those projects. By the way, just to mention that spike you see in Kubernetes around 1.5, that was when we started checking in a lot of generated code and then realized that was a bad idea and pulled it all out. SIG architecture has a code organization subproject that's thinking about this. There's also efforts to pull out some of the cloud provider dependencies and eventually all the volume vendors dependencies as we migrate to CSI. So I'm optimistic that that graph will start trending down in the next year. So secure defaults. We talked about this one last year too. And we made a little progress, but it's still very hard to change defaults. And a lot of the problems that existed a year ago, we still have that kind of problematic state. SecComp is an example that gets brought up all the time, but there's many others as well. And so if we haven't made a whole lot of progress here, maybe we should talk a little about whose responsibility it should be to actually fix these defaults. If we do it in core Kubernetes, this is kind of when you think of secure default, you think of, well, we should change it in the upstream project. That is obviously nice because we get the maximum reach and consistency by having the defaults in core Kubernetes. But it's also the hardest to roll out. We don't always have a good idea of who is running what in the open source project. We don't have that direct line to the users and the customers in the same way that like a vendor might. So maybe it falls on the distributors, the cloud providers, kubeadm, different cluster bring-up tools. There's more power and maybe even more incentive to roll out secure defaults among the distributors. But it also fragments the ecosystem, especially if those distributors don't agree on what the most secure default is or what the right default is. I actually think that this is inevitable. I think if we don't fix this in core Kubernetes, then there's going to be more and more pressure on the distributors to set the defaults right and kind of fix the perception there. And so my concern is that if that's inevitable, then are we going to inevitably fragment the defaults and the default state through that? Or maybe it falls on the users. This is sort of the current state and arguably not actually what it means to be secure by default. But it sort of falls on an ecosystem of consultants, tools, and vendors to help users get that default state right. So Kubernetes security has matured. We have this product security committee that we're at I think 7 full members. And we've launched a bug bounty. We're launching the bug bounty. We've got this audit thing that we've got a lot of great results from. And so, yeah, I would say that the project is maturing nicely from a security perspective. I think misconfigurations are still the primary pain point from a security perspective and the main source of compromise that we've seen. So I'm hoping that this will be a big theme going into 2020, is trying to get to a better state of secure defaults and secure configurations and try and fix some of this perception that Kubernetes is not that secure. And then in scare font, we have supply chain. This is something that it scares me because I don't feel like I have a very good understanding of the problem. There's a lot of different work going on in Kubernetes across a really big surface area, and I don't think that we have really good visibility into every piece of the supply chain. So I think this is going to be something that continues to be a theme for security going forward. So if you'd like to help out with any of these efforts, I've put up a bunch of information here on how to get involved. The security process, this is sort of what we do in the product security committee in responding to vulnerabilities. We're not looking for new members for the security committee right now. We need to keep that small because of the sensitivity of the information we deal with. But there's a lot of good ways to get involved there. Specifically, I labeled a bunch of issues as help wanted if you'd like to help with the security process, fixing that. The Security Audit Working Group is getting ready to do another round of audits of all of Kubernetes, and they're looking for volunteers to help out. If you're interested in the supply chain problem, the Kubernetes Infrastructure Working Group owns the image promoter, and they're doing a lot of great work around that. And then, of course, release engineering and how we build releases. For dependency management, that's being owned and driven by the code organization subproject of SIG architecture. And SIG, secure defaults sort of spans the whole organization. So that's what we have. Thank you. And there's a link to the slides at the bottom there if you want to go back and pull from any of these links.
Got one over here. Mo will at least entertain us.
So on the vendoring thing, so I've been following like Jordan Liggett did the work to move us to go mod or start the process with piles of bash scripts. At the bare minimum, should we try to forcibly update all of our deps to the latest and greatest and see if CI still passes?
Is there anyone from code organization who wants to talk to that point? I can take a stab at it. So we're starting to do that with some of the dependencies. I think that actually the golang.org/x dependencies that I kind of sort of pulled out of that graph there, we are updating with every Kubernetes release. It's hard. Some of the problems we have with dependencies today are there's no clear owner of the dependencies. Who knows what this thing is actually supposed to be doing? And so if we so combine that problem with the lack of test coverage, I don't have a lot of confidence that I can just update this thing to the latest version and not only not break anything, but have confidence that I didn't break anything. So I would definitely like to see us work towards that, but I think that just blanket updating everything to head would probably have some consequences.
Yeah, so when I was working on OpenShift, we kind of gave up on this problem, and we basically said that if you know what you want for some dependency, like a branch or a version, fine, you stick that in, glide. Everything else, we're going to force update the master. If it breaks, go fix it, right? And it made bumping dependencies extremely painful because you would get random breakages and really large diffs. But the flip side of it is we were really current on things. So there was some random HTTP2 bugs that we never hit because we'd actually accidentally, inadvertently bumped that library far enough that we had gotten the fix and before we realized we actually needed the fix. So there was some benefits here and there, but maybe that's too aggressive for a very large open source project that's not a product that's manned by one company like Red Hat did. I just wonder, like, to a certain degree, like, certainly, like, we get decent compile level errors when, like, just the API of a repo changes. Obviously, you can change the body of a function to do something completely different and leave the inputs and outputs looking exactly the same, and then sad things happen.
Yeah, it's a good point that we should follow up on.
So the discussion around getting rid of PodSecurity policy and introducing something else. So are we gonna just include something as a controller there, or I mean, what I'm trying to get to is, are we going to have something from the outside, or do we want to build it inside the Kubernetes? Because all the things that were listed in the slide, we can still use them today, right? Mm-hmm. So what's the committee thinking about that?
So this is still definitely an active area of discussion. The current direction we're leaning is towards pulling PodSecurity policy out of core Kubernetes and using admission webhooks, basically. So there wouldn't be a core solution there. We won't do that until we are confident that we have a good recommendation and a good migration path to something outside of core. Yeah, come to Sagoth and talk more about that.
And about the secure defaults, so like as someone who is working in the upstream, like, can't we, like, isn't this the right time to force the secure defaults, even if it's a breaking change? How much of a resistance do you think you'll get, and at what levels?
Yeah, it's a complicated question. I am certainly biased coming from the security perspective towards, let's do it, and just, it's going to be painful at any point. But we definitely don't want to just break users. If we make it too painful to upgrade to the secure defaults, then what happens is people just don't upgrade. They say, I know you're going to break me, so I'm just going to stay on 112 for 4 years. I'm just going to stay on this old version and not get all of the security patches that are going out. So that actually ends up leaving users in a worse state. So it's a pretty complicated question. And how can we do this in the least painful way, but still end up in a more secure state?
It's especially tough considering the broad variety of types of users we have. We have some people who would be fine if we just broke them every time and then they could quickly catch up. We have other users who reacting to that sort of thing is a company stopping process. So it makes it difficult to do just at the one level.